Yeah, so first of all, I would like to thank the keynote speakers from my session for inviting me to give a talk here, and also especially the organizers for allowing me to talk remotely. I could have loved to be there with you guys, but with two little kids, I'm not able to travel as much as I would like. But hopefully it will work after these initial problems. So yeah, today I'm going to be discussing the ancient DNA evidence that we have for the arrival of Steppe ancestry to the Iberian Peninsula. But before we go into it, I think it's worth reflecting upon two important aspects about the study of history, and in this case, prehistory with ancient DNA. And the first one is actually, why is DNA useful to study the human past? And is it useful because there are two different processes, mutation and drift, that create genetic variation. So not all of us have the same genome. We, on average, have around like 3 million differences, 3 million base pairs that are different between the different individuals. And this is the basis for all the analysis that we do. And also the second important characteristic, might seem obvious, but it's important, is that the DNA gets transmitted from generation to generation. So my DNA comes from my father and from my mother, and there is no escape around it. And the implication of these two characteristics, we can think about one population living in this place, and if this population splits into two that stop reproducing with each other, and then over time, over thousands of years, they will accumulate genetic differences. So some variants that are present in one population and not in the other, but most commonly will be genetic variants that are present in both populations, but at very different frequencies. So here I'm just representing them with these dark colors to say that they are starting to differentiate, but if we wait even more thousands of years, then we'll accumulate even more differentiation, and at the end we will be easily able to differentiate them with ancient DNA data. Now, if we have this situation and 500 years later we see that there is the DNA with the characteristics of the green population in the north, and we see appearing it in the south, then there is only one way to explain this. Is because people from the northern population move to the south, because DNA doesn't travel on its own; it's travel with the people that carry it around. So and I like to show this with this metaphor, of the footprints that allow us to follow the trail of somebody along the way. And DNA, since we carry it with us wherever we go and transmit to the following generations, allow us to track the populations as they move around the globe and as they are mixed with each other. So it's just a tool to follow the trail of human populations. And the second aspect that I think is important to take into account is that we have been immersed over the past decade in the so-called ancient DNA revolution. And this is triggered by the development of a new way to sequence DNA, is this next generation sequencing techniques that allow us to now sequence millions of DNA molecules in parallel. And before we could only sequence a few dozens. And we are not gonna go into a lot of details, but just the result of this is that with the first generation sequences before 2010, in ancient DNA samples, we were only able to retrieve empty DNA. And now with the new techniques over the past decade, we have been able to recover nuclear genomes. And this is key. And we're gonna see why is this so important. So we can imagine this genealogy, and we can imagine that we recover the mitochondrial genome from this individual. And if we go just 2 generations back, the mitochondrial genome only gives us information about 1 out of the 4 ancestors this individual has in this generation. And this is because the empty DNA is inherited directly from the mother, so it doesn't recombine. So we might think, okay, just 1 out of 4 is not that bad. But if we go, instead of 2 generations, 10 generations back in the past, this individual has around 1,000 ancestors. And the empty DNA only gives us information about 1 of them. So the one that is connected through a strictly matrilineal descent. So we see that the empty DNA is actually giving us a very partial view of the ancestors of this individual. And in this case, like only 1 out of 1,000. So what happens when we get the nuclear genome? So as Alisa did, I'm going to show my own example. So these are my chromosome 1, for instance, but it's the same for the other chromosomes. But my paternal chromosome, for instance, has 2 segments of DNA, one here and one here in darker color, that comes from my paternal grandmother. And I also have 3 segments, one here, and one here, that comes from my paternal grandfather. So this is just to show that the nuclear genome is a mosaic of DNA segments coming from ancestors in the whole family tree. So it's only when we get the nuclear genome that we can access information from the whole range of ancestors. And only when we have like hundreds of millions of genetic markers along the nuclear genome. And this is the basis of this revolution that we have been experiencing. Because now we probably many of you are familiar with the mtDNA studies because it's been going on for decades, but now we have to take into account that we now have orders of magnitude more information. We can study much better the ancestry of a given individual than we could do with mtDNA. So after this, just 2 important aspects, now we are going to go into the topic of the talk and what is the available data that we have. So in Iberia, in the 3rd millennium BC, we have 184 individuals. And in the 2nd millennium, we have 164 individuals coming from these very different papers. And as you see, there are some holes. For instance, in Galicia, we don't have any data, but in general, we do have representation from many different areas. It's not that we have just data from one particular region. And all these different studies agree that there was a demographic change during the 2nd half of the 3rd millennium BC. And how can we know this? So we can propose model 1, for instance, and the null hypothesis in this model is that the Bronze Age population from the Iberian Peninsula descend directly from the Chalcolithic population. So all the DNA that we find in the Bronze Age will derive from the DNA that we have in the Chalcolithic period. And when we test this model, we get a p-value that is 10 to the minus 237. So it's virtually impossible to explain the DNA that we find in the Bronze Age as just deriving from the DNA that we get in the Chalcolithic period. So it's pretty clear. And we can propose a second model in which the DNA that we find in the Bronze Age is actually deriving from the local population from Iberia, but also from Central European Belviker associated groups. And when we do that, we get a very good fit. So we are pretty sure that this is the correct model. So the Bronze Age population from the Iberian Peninsula derived from a mixture between the local populations and these Central European populations. And I have represented the Central European Belviker groups here with 2 colors on purpose, because we of course know that the Central European Belviker groups are not entirely steppe ancestry. They don't have 100% steppe ancestry. They are like a mixture of more or less like 50-50 mixture between a steppe ancestry and local Neolithic ancestry that was present in Central Europe and in Eastern Europe during the Neolithic. So now we can run this model too for each individual, and we get this plot, which is very similar to the one that to the PCA that Alisa saw, but instead of having PC2 here, we have directly the proportion of Central European Belviker related ancestry. And if we want to estimate the amount of steppe ancestry in this plot, we just have to divide these values that we get by 2, because we know that these groups are 50-50 between the steppe ancestry and local Neolithic ancestry. And in this plot, each circle is one individual, and what we see clearly is that before 2500 BC, we don't see any individuals with steppe ancestry, with Central European related ancestry. But then between 2500 BC and 2000 BC, we still see a lot of individuals that are direct descendants of the previous local Chalcolithic populations, but we see this new type of individuals arriving into the Iberian Peninsula. Are all these with high percentage of Central European related ancestry, some of them even with entirely Central European in ancestry. And then after 2000 BC, we stop seeing individuals that are direct descendants from the previous populations, and we see this Bronze Age population that is a mixture between the local populations and these new incomers that we have here. And this has been known already for 4 or 5 years, and we pretty much agree that this is true, that Bronze Age population from the Iberian Peninsula do not descend directly from the previous Chalcolithic populations. But of course, we have to look at in the details, because that is where the interesting findings arrive. And we are going to be looking at 3 different aspects of the demographic change that we clearly see. The first one is the route of entry and the timing. And of course, we can hypothesize several routes of entry. We can think that they came through the Eastern Pyrenees, through the Western Pyrenees, through a land route, but we can also hypothesize that they came maybe through a maritime route through the Mediterranean coast, or through a maritime route from the Cantabrian coast. So let's see what we can say. If we look at these very earliest individuals with the steppe ancestry, that had like the highest amount of steppe ancestry, where are they located? So we find them here in central Iberia, so in the region around the Madrid, the capital. Also, we find it in the northern Meseta here, very close to the natural corridor connecting the northern Meseta with the Western Pyrenees and with the Ebro Basin. And we also find them in the northern Cantabrian coast. So this is sort of suggesting that probably the route of entry was either through the Western Pyrenees or through the Cantabrian coast. And now we're going to be seeing who are these individuals. We are going to see like just a few examples. So who is the individual with the highest amount of steppe ancestry? And here, this would be like an individual with entire Central European related ancestry, but we don't know whether it was this man or all his ancestors that were migrating from Central Europe. But in any case, it was excavated at the site of La Magdalena in this very sort of rare tumuli with this rectangular shape, and it's an adult male. It has 3 bell beaker vessels, a palmella point and flick knife, and it's not directly dated, but from archaeology we know that it was pretty much around, it was definitely during the second half of the 3rd millennium BC. So this will be like the individual with the highest amount of steppe ancestry. You see some picture of the grave goods, and within the same site, within the same Belbeker necropolis, we find a woman in an artificial cave, and this woman doesn't have any steppe ancestry. So this is telling us that these 2 groups, the incoming groups from Central Europe with the steppe ancestry and the local populations, were actually interacting. They were not separated from each other. They were burying the dead at the same places. The second sample that we are going to be looking at is this individual from the Arroyal site, and this is the earliest directly radiocarbon dated individual that has steppe ancestry, and this is the radiocarbon date, and it's a young female buried again with 2 bell beakers, 2 carinated bowls, and this site is particularly interesting because it was used during the late Neolithic as a collective burial. It's actually a megalith, and then it was closed, and hundreds of years later it was used during the Chalcolithic as well, and they use it for 10 consecutive burials, and this young female is the last burial, and it was surrounded by the long bones and skulls of the previous burials. And we have data from 3 individuals around her, and 2 of them are a father and son, and neither of the 3 of them has any steppe ancestry. They will fall in this plot here. So this is again, these 2 groups are clearly interacting. They are being buried at the same places. And then the last example I'm going to show is these two men from El Hundido, which is again in this area in the northern Meseta. And these are these two individuals that are marked here. So interestingly, these are paternal third-degree relatives, but as we see, they do have some differences in the ancestry proportions. And why is this important? So if you have two different populations with different ancestry that start mixing, in the first generations after a mixture, you are going to see close relatives with different ancestry proportions. And then after many, many generations, this ancestry proportion get homogenized. So this is telling us that this was actually active admixture, that there was ongoing admixture at this particular time. And these are again buried with as well bell beakers. So this is a recurring theme. All these individuals, the earliest individuals with the steppe ancestry that we see in the Iberian Peninsula, they tend to be these typical individual burials with bell beakers and with other elements in the bell beaker package. And now we can also look in the Bronze Age, and we see that there is some variation in the ancestry proportions. And I can tell you that the ones with a slightly higher proportion of Central European ancestry tend to be in the north of the Iberian Peninsula, and the ones with lower proportion of Central European ancestry tend to be more in the south. And this fits very well with the finding from Vanessa Villalba Moco et al. In 2021, where they described the first appearance of steppe ancestry in the southeast around 2200 BC. So we can hypothesize, that these groups enter from the north, then around 2500 BC, and then it took them some generations, some probably a couple hundred years to reach the south, and by the time they reached the south, they had already admixed with the local populations, and that's why we see the Central European ancestry a little bit diluted in these southeastern populations. And we keep saying, that this process took place between 2500 and 2000 BC, so during 500 years, but actually if we look at the specific regions, this process might have taken much less time to unfold. In the southeast, for instance, they document that after 150 years after the entry of steppe ancestry, basically everybody has that type of ancestry. So probably within its region, it was much faster than 500 years. And now we're going to look at the proximal origin. So we know that the distal origin of these migrations is on the steppe, but we know that the steppe people didn't fly themselves onto the Iberian Peninsula. So they must be coming from somewhere from proximal origin. So to look into these questions, we are going to be using again IBD. Alisa already explained very well the basis of the method. I'm just going to say a couple more things. So this is a method for detecting distant relatives, and it's going to be published over the next few weeks. It was Harald who developed the method, and the good thing about this method is that it allows us to detect distant relatives. With the current methodology, we are only able to detect very close relatives, and here you can see just an estimation of the amount of cousins depending on the degree. So we tend to have around like an average 5 first cousins, but if we go to third, fourth cousin, we start getting like hundreds or even thousands of relatives. And this new methodology allows us to access all these connections, more distant connections, rather than the current methodology that only allows us to detect close relatives. And why is this important? So we can imagine one individual born in southern France who moved to the Iberian Peninsula and died in the Iberian Peninsula. And if we want to directly detect this connection with ancient DNA with the current kinship methods, we will need to excavate and analyze either this individual himself or any of the few close relatives that he has in the Iberian Peninsula, and also at least one of the very close relatives that he has in in southern France. Of course, this is very unlikely because the as it was mentioned just before my talk, the archaeological record is fragmentary, so it's extremely unlikely that we will find a close relative in both places, and that's why we have been able to detect very, very few close relatives across sites so far. But with this new technology, we no longer need to rely that much on luck, because we just need to recover and to excavate and analyze one of the hundreds of many or maybe thousands of relatives that this individual has in the Iberian Peninsula, and one of the hundreds or maybe thousands of relatives that this individual has in his original location. So now it's way more likely that we will be able to find these connections that reveal actually somebody that moved from one place to another. And so what I did is just to run this method in our Iberian individuals with the Steppe ancestry, both in the 3rd millennium and the 2nd millennium BC. And as Alisa, I also found many connections. And here I'm just showing the top 25 connections, which are, we cannot know for sure the exact degree of relationship, but are on the order of 3rd cousins. So as Alisa said, that would be sharing like 2 ancestors, 3 or 4 generations back in the past, which is, we tend to say that these are distant connections, but they're not actually so distant. I know, for instance, like my kids have met some of their 3rd cousins, so it's not super distant. And what do we find? So we have find like the vast majority of connections actually connect individuals in the Iberian Peninsula, mostly those very early ones with the Steppe ancestry, with individuals mostly in Central Europe. And this is of course amazing because we already know that there was like Central European populations arriving in the Iberian Peninsula, but now we can actually directly see the connections between actual individuals. So it's like another level of information that we have now. And we are going to be looking at some of these connections, same as Alisa did. We found, for instance, one individual from Almoloya, which is a site from El Argar culture, and connects with one individual from the Lech Valley, from Alisa's paper. And this is a Bell-Beaker associated individual. We also find, I think this Volker will like this one, we find a connection between a Bell-Beaker associated individual from Albur with an individual from Camino de las Yeseras. And this is a little girl is buried here. I think we already saw this picture in one of the first days of the conference, but this would be this girl here that is buried together with an adult female who is not her mother and doesn't have any Steppe ancestry. She does have a lot of Steppe ancestry, but she doesn't have any. So it's again another evidence that this population are interacting. They are buried together, even in the same grave. And just another example, we have one individual from El Arroyal. We already talked about this site before, connecting with an individual from Bohemia, a Bell-Beaker individual. So I think, again, this is a recurring theme in both, for the majority of these connections that we find, in both ends, we get a Bell-Beaker associated individual. So it does look that the introduction of the Steppe ancestry to the Iberian Peninsula was mediated by Bell-Beaker associated groups. And the third aspect that we are looking at is the models of interaction. So, we have clear evidence that these groups were interacting with each other, but how? What was the nature of the interaction? And you probably have noticed I still haven't talked about the Y chromosomes, but here it comes. And I'm going to show again like a very similar plot as Alisa did. Here I'm going to color the male individuals in this plot with the Y chromosome haplogroups. And we see this very striking pattern, whereas all the haplogroups that were present during the Chalcolithic, during the Neolithic period, G2, H, I2, almost vanished and are replaced by this R1b P312 that is common in the Central European Bell-Beaker associated individuals, We see it in the earliest individual with the steppe ancestry, and then everybody basically in the Bronze Age has this haplogroup. And this is the plot from our 2019 paper, where we didn't find any other haplogroup during the Bronze Age, but we now have many more individuals, and I think we have a couple of them that don't belong to this R1b312. So instead of being 100% replacement, maybe it's now like a 95% replacement, which is actually, I think it's much more easy to explain, because when I was thinking about this, I think how could it be that not a single local lineage survived? And it doesn't make any sense, because these men didn't have DNA tests. They didn't have any way to test whether to test for paternity of their own children. So it makes much more sense that at least some of the local lineages survive, even if there were very, very few. And so how can we interpret this? So we find in the autosomes that Bronze Age population have around there's some variation, but around 40% of ancestry from Central Europe. But if we look in the Y chromosome, it's almost 100% of ancestry. So what does this mean in actual terms, in real terms? So we can imagine again a genealogy of an Iberian individual living in the Bronze Age around 1700 BC, and we can imagine the genealogy back until 2500 BC. And in this generation, this individual will have around 40% of his ancestors living in Central Europe, and around 60% of his ancestors living in the Iberian Peninsula. And this will be more or less randomly distributed in the family tree. But now if we look at the ancestor that is connected to him through a strictly patrilineal line, this one will always be a Central European ancestor. So while in this case, you can be like randomly distributed, here, this will always be a Central European ancestor. No matter which individual you put here, this will always be Central European. So it's telling us that there is something special about this patriline that is different from the other lines of descent. And of course, we can propose some models to explain this clear evidence that we find. And one model is widespread violence. This is the model that the journalists really like. And in this case, we can hypothesize one population in coming groups from Central Europe, maybe mostly men that arrive, then kill all the local males, reproduce with the women, and then we will get, the result will be like an mixed population, but with all the Y chromosomes coming from the incoming groups. This is, of course, not very likely because we don't find the evidence of widespread violence during this period. So it could have some impact, but it cannot be like the whole explanation. Then we have disease. I think we talked about this in the first day of the conference. We can hypothesize one disease that maybe was brought by these incoming groups, or instead was present in the local population and decimated the local population, and that created that allowed the newcomers to then overcome demographically the local population. And this, of course, again, can have some impact, but unless we are willing to assume that there is one disease that kills the man and not the women, then we need something else on top. So this can have some effect, but we need some other process going on to explain why all the local Y chromosomes disappears after 500 years. And then we can think about like more complex social process in which we have these incoming groups being strongly patrilineally organized, and then maybe they have preferential access to resources, and this gives them higher reproductive success than the local clans. And this, of course, the sons of these individuals inherit the higher social status and have themselves higher reproductive success. And these generations after generations, taking into account the exponential growth, as I think Martin mentioned this, in some generations, you can get just one lineage, dominating over the other. But under this model, doesn't mean that the local male just suddenly disappear or that they didn't have descendants in later generation. It means that they don't have descendants through strictly patrilineal lines. So just to visualize this concept, I have this figure here, and we see that the local males here in blue do have descendants in the last generation represented here. But if we just look through patrilineal lines only, we see that all these males in the last generation, they trace their patriline to an incoming male, and the local paternal lineage get extinct at some point. So this is just to show that we are not saying that they vanish or that they don't leave descendants in the later generation. In fact, I can have plenty of grandchildren, but if my sons only have daughters, then none of them will be related to me through a strictly patrilineal line of descent. And of course, we can have like a mixed model in which we have like some involvement of each of the different models. And we have, for instance, we can think about the European colonization of the Americas, and we know pretty much what happened, and we know that there was definitely some violence involved, definitely a lot of disease involved, and also some social processes that actually created some genetic patterns that are pretty similar to the ones that we see in the Chalcolithic and the Bronze Age. Maybe not as extreme as those that we find in the Bronze Age, but are pretty similar. So there could be the contribution of this different process. And now what we need is actually to zoom in and do ancient DNA studies at the local scale to understand how these populations were interacting, but at the local scale, which is where they actually interacted. And we are starting to have this type of studies, and I'm going to talk about this one from Vanessa Villalba Moco and also from Wolfgang, in which I have the pleasure to make a very small contribution. And in this study, we work on the Almoloya site, and then we get data from 68 individuals, genome-wide data. And what do they find? So they investigate double burials, and there have been some hypotheses about double burials, whether they were heterosexual couples, or also whether they were, matrilineal relatives. And when you analyze the data, you see that these individuals here buried in the double tombs are completely unrelated to each other, and they also have offspring in common, at least in 3 cases. So this is clearly there were heterosexual couples. Then they also have some double burials of infantiles, and in this one case, they were 2 paternal half-sisters buried together. It will be this woman here, these 2 women here. And so it's telling us that there were men having children with more than 1 woman. And for us, the more interesting patterns that are found is patrilineality. So they have this family, for instance, over 5 generations, and what connects the first generation with the last one? So it's a chain of three males. So this is clearly that there was patrilineality going on, at least in the funerary domain. And they also find some evidence for patrilocality. For instance, the adult women are unrelated to each other, so they are coming from different communities. And I think this is a really cool result. We might have like one of the first direct evidence of female exogamy, because we have this family trio from Almoloya, a mother, father, and son. And then we have this woman that was buried in Mother Mercedaria's site, around 40 kilometers away. And it's very likely, the data is really low quality, but it's really very, very likely the daughter of this man. So she was probably born in Almoloya, and then she moved and was buried in Madres Mercedaria. So it does seem that, at least from the data we have so far, that during the early Bronze Age, the groups were practicing patrilocality and patrilineality. But what happens that we also have just 2 big families from the Neolithic, one from our paper from Hasselton North in southern England. This was like a high status tomb. And we also have the really large family from Gurgi. In this case, it's a plain cemetery, so probably used by the medium or low class. But in both cases, we have a strong signal, again, of patrilineality. In the case of Hasselton, is strict patrilineality. And in both cases, again, a very strong signal of female exogamy. So it doesn't seem that exogamy and patrilineality was something new for the European populations and from maybe Iberian populations in the Bronze Age. So there must be something else that these new groups brought to the Iberian Peninsula to explain these very striking patterns that we see in the Y chromosome that are not present in the previous periods. So now just let me wrap up the talk with the conclusions. We find groups with the steppe ancestry first appearing in central and northern Iberia around 2500 BC, so very similar to the result Elisa showed for Italy, and they reached the southeast by 2200 BC, and by 2000 BC, basically everybody, at least in our data set from north to south and from west to east, has ancestry from these newcomers. And within each region, this change was probably occurring much faster than 500 years. It was maybe like in 200 years, basically everybody had ancestry from these new groups. We can hypothesize that the route of entry was very likely through the Western Pyrenees or through the Cantabrian coast. And we find that the earliest individuals with the steppe ancestry were associated with bell beakers. And on top of that, they were actually third cousins of Central European bell beaker associated individuals. So very likely the steppe ancestry was mediated into the Iberian Peninsula through bell beaker associated individuals. And finally, with the data we have now, it seems that the early Bronze Age communities were practicing patrilineality and female exogamy, but this seems to be already common in Neolithic communities, at least in Northern Europe and Central Europe. So maybe there was a new type of social organization around patrilineality that was brought by these new groups. I think it was also mentioned in the first day of the conference that patrilineality is sort of an umbrella term, but there are many different ways of organizing a community around patrilineality. So maybe there was something new about patrilineality that these new groups brought. And of course, as always, we need more research to understand how these populations were interacting. But this, of course, this is a super interesting topic, and I'm willing to see much more research being done in this, both archaeological research and ancient DNA research being done in this topic. And yeah, I would like to thank you all for your attention, and I'll be happy to take any questions.